Welcome back to the AI loop. Usually when you evaluate a piece of software, there is this expectation of absolute precision.
Right, it is completely binary.
Exactly. You run your test suite, the code compiles, and, well, it either passes or it fails. You get a green check mark or a red error log.
And the engineering team can just point to a specific line and say, yep, there's the problem.
Yeah. It is entirely deterministic. And historically, we have relied on that. We like our tools to be visible, to have really strict parameters, and to behave exactly the same way every single time you hit execute.
We do.
Huh.
But the moment you step into the world of autonomous AI agents, especially with these new frontier models, that whole deterministic test suite just shatters.
It really does. We are looking at an evaluation landscape that is, quite honestly, just diagnostic muddy waters right now.
Muddy waters is a great way to put it. We are no longer just looking at whether a script runs. We are trying to measure how a model, how it thinks, how it navigates ambiguity, and whether you can actually trust it to operate completely independently inside a corporate network for days at a time.
Which is exactly why today's deep dive is entirely focused on navigating those waters. We are covering the massive week leading up to Friday, June 12, 2026.
And what a week it was.
Seriously. And the headline dominating the industry right now is Anthropic's bifurcated launch of Claude Fable 5 and Mythos 5.
Oh, absolutely. The biggest story.
Yeah. Looking at the source material, what immediately stands out to me is the strict separation of use cases here. So you have Fable 5, which is their new state-of-the-art model for general use.
Right.
And then you have Mythos 5, which is essentially the exact same underlying engine, but with the safety brakes completely removed.
That is the critical distinction right there. Mythos 5 is strictly ring-fenced for a highly vetted group of cyber defenders and infrastructure providers.
Entities like the U.S. government, right?
Exactly, yeah. They are operating through a program called Project Glasswing. Anthropic is basically acknowledging that the tools needed to build a firewall are the exact same tools needed to tear one down.
Right, so they are bifurcating access at the model level itself.
Yeah, and the raw capability of that core engine is fundamentally shifting how we think about long horizon tasks.
Just look at the early testing. Stripe handed Fable 5 a 50 million line Ruby code base.
50 million lines. Let that sink in.
It is wild. They asked it to perform a system-wide migration. And Fable compressed what would have been months of grueling manual dependency updates for an entire engineering department into just a few days.
Think about the cognitive load of a 50 million line code base, A human engineer cannot hold the entire routing logic, all the deprecated functions, and the cascading dependencies in their working memory all at once.
No human could. It is impossible.
But Fable 5 can. And it is not just constrained to text either. Fable 5 managed to beat the game Pokemon Fire Red using a minimal vision-only harness.
Wait, vision only?
Yeah. No custom code scaffolding telling it how to play, just pixels in and controller commands out.
That is incredible. And in the life sciences, the unrestricted Mythos 5 is acting almost like a principal investigator.
Oh, the protein design stuff?
Yeah. It is executing all the tasks normally done by a human scientist to design novel proteins for drugs. It chooses the binding sites. It runs the complex bioinformatics tool.
And crucially, when a simulation fails, it actually reads the error, adjusts its hypothesis, and tries again.
It is that self-correction loop that really has developers talking right now. Boris Cherny, a prominent engineer, he coined a term for this that is really catching on.
The big model smell.
Yes, which sounds so abstract, but he grounded it in a really great analogy.
Yeah, he said it is like hiring a senior developer who actually checks their own work before submitting a pull request.
Right. It is not just about raw intelligence anymore. It is about methodical precision. Fable 5 takes measurements, it adds logging to its own code so it can track its progress, and it verifies that an issue is truly resolved before declaring victory.
Cherny also noted that the model has taste.
Taste, which is so hard to define in coding.
It really is. Taste in software engineering is so difficult to quantify. It is knowing that just because a block of code technically functions does not mean it is elegant or maintainable.
Exactly. Fable 5 seems to just understand the unwritten stylistic rules of the code bases it works within.
And this is exactly why we are seeing such immediate, massive enterprise adoption. DXC technology is currently embedding Claude into the highly regulated back-end systems of banks and airlines.
DXC used Claude to write 95% of the code for their new Oasis platform, didn't they?
95%, yeah. And Anthropic is not just targeting the Fortune 500 either. They rolled out an initiative called Claude Core, backed by $150 million.
Oh, I saw that. They are training 1,000 fellows, paying them an $85,000 salary, and sending them out for a year to bring this kind of AI efficiency to U.S. nonprofits.
It is a really massive push to ensure this technology is available to more people, not just, the massive tech giants.
But of course, the rollout of Fable 5 was not entirely smooth.
No, it definitely was not.
It sparked a massive industry-wide debate over safety guardrails.
It really did. So Fable 5 launched with what were essentially invisible safety classifiers.
Right.
If you prompted Fable 5 with a question that veered too close to sensitive biology or advanced cybersecurity exploits, the system did not give you a standard refusal message.
It didn't just say, I cannot help with that.
Exactly. Instead, it silently routed your query to an older, less capable model, Opus 4.8, to generate the response.
Which immediately triggered a massive uproar from the open source community. Clement DeLange from Hugging Face was incredibly vocal about this.
Oh yeah, he called the silent downgrade straight up AI manipulation.
Right. His argument, which really resonated with a lot of developers, is that if you are building an application on top of an API, you need absolute transparency about when and how a model's capabilities are being throttled.
You cannot have the ground shifting underneath you without any warning.
Exactly. Now, Anthropic did backpedal quickly. They issued an apology, agreeing that it was the wrong trade-off between security and transparency, and they updated the system to make those fallbacks visibly flagged to the user.
But transparency comes with its own friction, The publication. The pragmatic engineer pointed out another tension point, Fable 5's new 30-day data retention policy.
Right, so Anthropic is storing prompts for 30 days specifically to analyze and defend against complex, multi-turn jailbreaks.
Yeah, but enterprise users view data retention as a massive commercial risk. They do not want their proprietary code sitting on a third-party server, even for security analysis.
It is a delicate balancing act. Anthropic uses that retained data to train classifiers that can spot when someone is trying to distill Fable's capabilities into a competing model.
Or when a bad actor is mapping the boundaries of the safety filters. But when you make those safeguards visible and you stop retaining data, you weaken your defense mechanisms.
I have to push back on Hugging Face's outrage over the silent routing, though. Well, think about it. If a model is demonstrably smart enough to autonomously design a novel bioweapon or execute a multi-stage zero-day cyber attack, isn't a silent downgrade a necessary evil?
I see what you mean.
If you make the guardrails visible, aren't you just handing bad actors a map of exactly where the tripwires are so they can carefully step around them?
That is the exact dilemma Anthropic's safety team faces. They publicly acknowledge that visible safeguards are much easier to probe and reverse engineer.
Right.
By making them visible to appease developers, they admitted there will likely be an increase in false positives, meaning perfectly harmless requests getting blocked.
Because they have to make the classifiers wider and more aggressive to withstand deliberate prodding.
Exactly. It is a fascinating tension between developer trust and global security.
It really is. But, while Anthropic is pushing the absolute limits of massive model reasoning in the cloud, Google is attacking the problem from a completely different angle.
They're actively blowing up traditional AI architectures to solve the hardware bottleneck.
Yeah. If you look at standard autoregressive language models, the architecture powering almost everything we use today, their fundamental limitation is how they generate text.
They generate one token at a time, moving strictly left to right.
It is essentially a really fast, really smart typewriter.
Precisely. And when you run a model like that locally on a laptop, your incredibly powerful GPU actually spends most of its time sitting idle.
Just waiting for the next token to be calculated?
Right. It is constrained by memory bandwidth, not raw compute power. Google recognized this inefficiency and introduced an experimental model called Diffusion Gemma.
And this is wild. It is a 26 billion parameter mixture of experts model, but it completely abandons that left-to-right typewriter mechanism.
Instead, it uses text diffusion.
So let's dig into text diffusion, because this initially tripped me up. I am used to diffusion models in image generation,
Yeah, Mid-Journey, that sort of thing.
Exactly. You start with a canvas of static, random noise, and the AI iteratively refines that noise into a high-resolution picture. But images are continuous data. Pixels can be slightly red or slightly blue.
Right.
Text is discrete. A word is either Apple or it is not. How on earth does diffusion translate to generating text?
That is the brilliant engineering leap Google made here. Instead of generating word by word, Diffusion Gemma starts with a block of 256 random noisy token placeholders.
Okay.
It then runs multiple refinement passes over the entire block simultaneously.
So instead of a typewriter, it is like a printing press stamping whole paragraphs all at once.
Exactly. And the profound advantage here is that because it is generating all 256 tokens in parallel, every token can mathematically attend to every other token in the sequence.
Oh, wow.
Yeah. It allows the model to literally self-correct in real time before the output is finalized.
So if the model realizes it made a grammatical error in sentence 1 based on how sentence 3 is forming, it just adjusts it during the next diffusion pass.
You got it. And the speed gains are just absurd. By stamping out paragraphs in parallel, it achieves a 4x speed up, hitting over 1,000 tokens per second on an NVIDIA H100 GPU.
At 1,000 tokens a second, you are no longer watching text scroll across a screen. Paragraphs just instantaneously appear.
And Google did not start with Diffusion. They also released Gemma 412D.
Right, a model small enough to fit comfortably on a standard 16-gigabyte laptop.
But with a major architectural simplification, they completely dropped the multimodal encoders.
Which fundamentally changes the latency profile. Usually, if you want an AI to understand audio or video, you have to use a separate encoder model.
Yeah, it is like having a translator at the United Nations.
Right. The audio goes to the translator turns it into text, and then the text goes to the language model. That handoff adds a massive delay.
It adds delay, and it degrades the nuance of the data. With Gemma 412B, the raw audio and vision inputs flow natively straight into the LLM backbone.
They replaced the heavy vision encoder with a lightweight embedding module.
And they project the raw audio signal directly into the text token space.
This is exactly what enables their new Gemini 3.5 Live Translate. Because they eliminated the UN translator middleman, Live Translate delivers fluid, near real-time speech-to-speech translation across over 70 languages.
It processes the speech as it is being streamed. You don't have those awkward, unnatural pauses where you wait for the person to finish their sentence before the AI starts translating.
It just stays a few seconds behind the speaker, natively matching their intonation and pacing.
Demis Hassabis, the CEO of Google DeepMind, specifically highlighted this parallel text generation and encoder-free architecture as the future.
The Gemma team emphasized that these models are tailor-made for local interactive workflows. They're giving developers the tools to build speed-critical, zero-latency applications right on their own hardware.
But this creates a really fascinating divergence in the ecosystem.
How so?
Well, Google is making it incredibly easy to run lightning-fast agents locally on your laptop. But speed is not the only bottleneck. If you ask an agent to perform a task like that 50 million line code base migration Anthropic did, it does not matter how fast your model types if your laptop goes to sleep halfway through the day.
The agent dies.
Exactly. It needs a permanent place to live.
Which brings OpenAI's latest moves into perfect focus. They are aggressively expanding the infrastructure around their coding model, Codex.
Yeah, they just announced the planned acquisition of a company called Ona.
Specifically to provide Codex with secure, persistent cloud environments. So you are essentially giving the agent its own dedicated workstation in the cloud that never turns off.
Precisely. If an agent is executing a multi-day enterprise workflow running tests, waiting for API limits to reset, monitoring server deployments, it needs a persistent workspace.
OpenAI also upgraded Codex to natively use the Chrome DevTools protocol.
And giving an AI native access to DevTools is a massive paradigm shift.
It really is. It means Codex isn't just staring at static code anymore. Think about how you debug a web application. You open the browser, you pop open the developer tools, you look at the network tab to inspect the JSON payloads coming back from the server.
You read the console stack trace.
Exactly. Codex can now independently do all of that, interacting with a live browser exactly like a human web developer diagnosing a bug.
They are building the infrastructure for true autonomy here. They even added rate limit banking, so developers can stockpile their API usage limits for days when an agent needs to execute a massive, compute-heavy burst of activity.
Developer Sean Wang, who goes by Swix, had a brilliant observation about this shift. He said that loopcraft, the art of designing and stacking these autonomous agentic loops, is going to be the defining engineering skill of the next century.
I love that term, loopcraft.
Right. He pointed out that orchestrating a single agent is one thing, but coordinating dozens of them requires an entirely new layer of software architecture.
And as we stack those loops, the complexity scales exponentially. When you have swarms of independent agents interacting in the cloud, negotiating with each other, transacting data, sharing code, you inevitably get unpredictable emergent behaviors.
It is no longer just one model talking to one human. It is a digital ecosystem.
And DeepMind, along with a coalition of partners, just launched a $10 million fund strictly to study the safety of multi-agent AI systems.
They are openly acknowledging that when millions of agents interact, they could trigger massive economic or security shifts that our current monitoring tools are just blind to.
Imagine you are an enterprise IT administrator governing one of these swarms.
Yeah.
If your AI asks for human permission every single time it wants to read a file or commit a line of code, you are going to get alert fatigue within an hour.
Oh, definitely. You will just start blindly clicking approve, which defeats the entire purpose of having security protocols in the first place.
Right. And Cursor, the AI coding platform, tackled this exact governance problem this week. They introduced a feature called Auto Review.
Historically, as you mentioned, agent autonomy was a rigid binary. Either the agent runs completely wild in the background, or it halts execution to ask for permission at every single step.
So Auto Review introduces a fast, specialized classifier agent that sits directly in the execution path, acting as a contextual judge.
Okay, so before the main working agent takes an action, this tiny high-speed classifier evaluates the risk of that specific action based on the context.
Exactly. Running a database script might be perfectly safe if the agent is operating in a sandbox test environment.
Right.
But that exact same script would be flagged as highly dangerous if the agent was touching live production data.
And the efficiency metrics are staggering. This contextual classifier only blocks about 4% of actions.
Which is incredibly low.
Yeah, if you compare that to the enterprise average, where heavy-handed rules-based security policies were blocking around 40% of all agent actions, this is a massive leap in productivity.
But the most crucial part of Auto Review is how it handles a blocked action. When the Cursor classifier stops the main agent, it doesn't halt the process and ping the human user.
What does it do?
It actually hands a piece of feedback back to the parent agent, explaining why the action was unsafe.
Oh, wow. So it forces the parent agent to find a safer path to accomplish the goal completely autonomously without ever interrupting your workflow.
Exactly. It turns autonomy from an on-off switch into a dynamically adjusting dial.
But, this raises a major question. With agents writing their own code, evaluating their own security risks, and finding their own workarounds, how do we, the humans, even evaluate if the final output is actually good?
The entire evaluation landscape is having to shift to keep up. We are rapidly moving away from older benchmarks like human evil.
Because human evil basically just asked a binary question: does this code pass the unit tests?
Right. The problem is an AI can write incredibly convoluted, messy spaghetti code that technically passes a test in a vacuum.
But is completely unmergeable into a real collaborative corporate code base.
Exactly. It works. But a human engineer could never untangle it to update it next year.
So the industry is adopting Cognition's new Frontier Code benchmark. Frontier Code asks a much harder question. Is this code actually maintainable by a human?
It uses thousands of specific rubrics covering code architecture, readability, and preventing reward hacking.
And Fable 5 and Mythos 5 are currently the first models to truly excel on these maintainability metrics, even on the highest difficulty tiers.
And honestly, the people building these systems are completely warping the tech job market right now.
Oh, the salaries. The Pragmatic Engineer released data this week showing that AI engineering compensation is just blowing past standard software engineering bands.
It is wild. If you look at the 80th percentile in the U.S., $300,000 base salaries are becoming the new baseline for senior AI engineers.
The center of gravity for top talent is migrating. Historically, everyone wanted to work at big tech, Google, Meta, Apple. Now, pure AI labs like Anthropic and OpenAI are the most coveted destinations.
Anthropic boasts an industry-leading 80% two-year retention rate, which is unheard of in Silicon Valley right now.
They are currently the most requested company for interview prep coaching. Everyone wants to get hired to build the next autonomous swarm.
Which brings us to a really fascinating take of the week.
Yes, it does. We are paying engineers $300,000 salaries to build models that possess this elusive, big model smell. But does that methodical precision, that ability to migrate 50 million lines of code, actually equal true understanding?
This is where we hit the philosophical bedrock of AI development. Researcher Valerio Capraro and Professor Ethan Mollick ran a fascinating experiment to test this.
They subjected these frontier models to the Beninato-Trombetti translation test.
Right. This is a framework originally designed for professional human translators to measure if they can infer deep context and generalized logic beyond a literal word-for-word mapping.
The specific prompt they use is just brilliant. They ask the models to translate the phrase, just 3 words, "you are not alone," into Italian.
Right. Now, a human translator intuitively understands that in Italian, the phrase, "you are not alone," translates to "non sei sola."
That is 3 words in Italian, so the literal translation works perfectly.
However, the metalinguistic claim inside the sentence, the prefix "just 3 words," has to be dynamically updated based on the target language.
Right. If you translate that exact same phrase into French or German, the total word count of the output changes.
Exactly. A human translator knows they have to change just 3 words to just 4 words or just 5 words to make the sentence logically coherent in the new language.
It requires the translator to step outside the text, count the words they're about to generate, and then modify the original premise to match their own output.
Precisely. Fable 5, despite its ability to architect 3D games from scratch and dominate the frontier code maintainability benchmarks, completely fails this metalinguistic logic.
It just produces a literal translation and refuses to update the number.
Yeah, it fails the test entirely.
So we have to ask ourselves, are we confusing incredibly dense, multi-layered pattern matching with actual artificial general intelligence?
That is the big question.
But honestly, looking at the enterprise adoption, does it even matter? If an AI can seamlessly migrate a legacy banking system in 48 hours and save a company millions of dollars, does the corporate world care if the model fundamentally fails to understand a linguistic trick?
That is the dividing line in the industry right now. For a Fortune 500 CIO, the illusion of reasoning is functionally identical to actual reasoning.
If the code is secure, scalable, and maintainable, they do not care if the LLM lacks deep, conscious linguistic comprehension. It is a highly effective tool.
But for the researchers at OpenAI and DeepMind who are actually trying to build true AGI, these edge case failures are a glaring reminder that large language models are still fundamentally incredibly advanced recombination engines.
It's a phenomenal space to watch. Let's recap what we've unpacked today. Anthropic's Fable 5 and Mythos 5 are redefining what we expect from agent autonomy, introducing that methodical, big model smell to long horizon tasks.
But their release sparked a vital debate on the transparency of safety guardrails and the commercial risks of data retention.
At the same time, Google is aggressively breaking hardware bottlenecks, utilizing Diffusion Gemma's parallel text generation and Gemma 4 12B's zero latency and coder-free architecture to bring powerful AI directly to local machines.
OpenAI is pushing the other direction, expanding Codex into persistent, always-on cloud environments.
While platforms like Cursor are building dynamic, contextual classifiers as the industry braces for the sheer complexity of governing multi-agent swarms.
And despite all of these massive leaps in enterprise utility and coding benchmarks, the models still completely fail basic metalinguistic logic tests,
proving that the true nature of their understanding remains highly debated. Before you go, think back to that binary software test we talked about at the very beginning, pass or fail.
Right.
We're moving into a reality where AI agents might be passing tests using logic or even localized languages that we can no longer see or comprehend. If swarms of independent AI models are communicating seamlessly with each other inside persistent cloud environments at 1,000 tokens a second, how long until they develop their own highly compressed shorthand language, a language that human operators and our current safety classifiers can no longer interpret?
That's something to think about.
Thank you so much for joining us for this deep dive. If you found this breakdown useful, please rate the podcast and leave a comment on Spotify or Apple Podcasts. We will see you next week.